All right. Welcome everyone to Builders Declare Australia's 24th webinar called A Little Pot of Gold. My name is Hamish White and I'm one of the founding members of Builders Declare and Director of Sanctum Homes, and I'll be your host for this evening. In the spirit of reconciliation, we would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to elders, past, present and emerging, and extend our respect to all Aboriginal and Torres Strait Islanders peoples today. Now, excuse me if I fanboy a little bit today, but we are joined by two people I have a very deep respect for, Talina Edwards and Andy Marlowe from Envirotecture. Talina and Andy are two of three directors of Envirotecture, the other being Dick Clark. In December 2022, Envirotecture and Talina Edwards Architecture merged practices, uniting their teams to be stronger together. They believe that the whole is greater than the sum of its parts, and the synergy created by this partnership will lead to greater impacts and better outcomes. Talina Edwards is a passionate advocate for building a better future by creating healthy, functional, comfortable, beautiful, sustainable architecture, which combines building science with biophilic design. Talina is Director of Envirotecture with over 20 years experience as an architect, specialising in sustainable home design. She's a certified passive house designer, was an AFA board member, was actively involved in the early days of Architects Declare, has trained to deliver living building challenge projects, and has won multiple awards and gained industry recognition for regularly sharing insights about the benefits of passive house. You've got a long rap sheet there, Talina. Well done. We are also joined by Andy Marlowe, Director of Envirotecture and Passive House Design and Construct. He holds both bachelor's and master's degrees in architecture. He's a certified passive house designer and had extensive experience in sustainable design at a variety of scales. Andy is driven by a desire for all people to live, work and play in buildings that make them happier. He believes that good design should be accessible and benefit all, not just who commission it. Today's webinar, A Little Pot of Gold, is a research project that set out to answer one question: should we be reaching for stars or are we chasing rainbows? Drawing insights from the Little Pot of Gold House research, today's webinar will hopefully enlighten you about the complex relationships between operational carbon and embodied carbon, NatHERS and PHPP, and how to achieve a more equitable, affordable and healthy true net zero home for all. This presentation was at the Passive House Conference this year, which I was fortunate to attend. And there is a little bit of assumed knowledge of the principles of passive house, that being thermal bridge-free construction, air tightness, high performance windows, continuous insulation, and the use of an HRV. Let's kick off today's event. Now, the information you're about to receive is based on the experience of the presenters and may not relate to you or your situation. If you would like more specific advice, please get in touch with us via email. Today's webinar will be about 35 to 40 minutes, and there'll be some time at the end for some questions as per usual. So without further ado, I will pass over to Talina if you want to start your presentation.
No worries. I will get my screen share working. Is it up? Are we good?
It is up. It is up.
Excellent. Thanks so much for having us, Hamish. It's really fun to be here. We love the work that Builders Declare are doing, and we've got a fair bit to get through, so I will jump straight in. I'd also like to pay my respects to the Wadawurrung people whose land I'm tuning in from today in sunny Ballarat. And yeah, pay my deep respects to them as the traditional owners of this land. And today we are talking about the little pot of gold. Should we be reaching for the stars or are we chasing rainbows? And this was our exploration into a true zero carbon home. So why do we care about true zero carbon? The bad news is at the moment, the construction industry really is responsible for over 40% of global carbon emissions. And we really need to change this yesterday. So the good news is we are 40% of the solution. So we can do something about this, and we know how. So once upon a time, we decided to enter the Design Matters National True Zero Carbon Challenge. So this was last year. They are running it again, and it was an excellent competition. They are true advocates for learning more about sustainable design. So we applaud that and encourage people to get on board. Now, the competition was about designing one home in one capital city and making sure it was true net zero. And there were a bunch of parameters around that and sort of steps to follow to get there. And we did have to hook up with an energy rater. And at the time, my practice and Andy's practice joined forces together and thought this would be a fun thing to do. And we decided to take it a little bit further and turn it into a bit of a research project. So with operational energy, we can measure that with a relatively high degree of accuracy, depending on what tools you are using. But a typical Australian house is only about 16% of embodied carbon in the whole house, but everything else is operational energy. And the biggest one, this is nationwide here, 32% for heating and cooling. In my part of the world, that's way over 40%. So we know with Passive House, we can reduce that substantially. Now with embodied carbon, it can't be measured in the same way, but it can be calculated. And a typical building on the left, at the moment, as we said, it's only a small part of the pie. But as we are reducing this operational energy, which we want to be doing because we know how, then it means the embodied energy becomes kind of 50%, and it balances out, and we do really need to look at both. They are both important. And we used to call this a high performance building to meet the Passive House standard, or to, be reducing the operational energy in this way. But now we actually call it appropriate performance because it's a building that's doing what it's meant to be doing. So as we started this competition entry, we made an observation around the current state of the industry and the NatHERS star rating, and how sometimes you could try and get 8, 9, 10 stars, but were you actually getting what you paid for? Were homeowners getting what they paid for? Were they seeing the results that they thought they were hoping to receive? So we decided to call this should we keep reaching for these higher stars? Will that give us what we think it is? Or are we just chasing rainbows and never really getting to the end and getting what we seek? So we wanted to find out if some of these assumptions were true, and we did a bunch of research to find the answers. We didn't know. So this did become a bit of a science experiment. We did a bunch of hypotheses to find out. We set these up to go, let's see if we can find the answers. And the first one is all about embodied carbon. We all know the story of the big bad wolf, and that apparently bricks are better, or high thermal mass is better. And we know that NatHERS and star rating do favor that thermal mass for the thermal performance. And then over the life cycle, surely it must offset the additional embodied carbon associated with it. But we weren't sure if that weighs up more than other insulation. So we wanted to test this theory to understand if maybe more bio-based materials actually could work better. Secondly, we asked the question, if the nation relies on NatHERS stars for better comfort outcomes, if the nation relies on NatHERS stars for better performance outcomes, does this result in performance gaps? And we will explore this more as we move forward. Thirdly, we are the fair go country. Our housing system is equitable, or is it? And this was just something that we realized not everyone knew about when it comes to, say, a 7-star home, and what that might mean in different parts of the world, and also in different parts of the country, and what that might cost. And lastly, we looked at affordability. So building costs are rising. It's not affordable to build better quality, or is it? So we did a bunch of analysis around that. And because this was a bit of a research and science experiment, we did have a methodology to our madness. So not only the one home design, there is one house, but we modeled it in 6 capital cities. And then we looked at 4 different versions of it. So the first one was passive house with low embodied carbon. So it was timber framed and had either straw or hemp as part of its construction and insulation. We did a passive house with medium embodied carbon, which was more of a typical timber frame building with insulation bats. And then thirdly, we looked at a passive house with high embodied carbon. So there was a reverse brick veneer and a slab floor, whereas the other options had timber frame floor. And lastly, we looked at a NatHERS high star rating to try and push as high as to 10 stars as we could. And we called that one Chasing Rainbows. And this will make more sense as you see some of the graphs. So we did 24 in total. So there was a cast of thousands. We had a big team helping us out from our 2 design practices at the time, and our consultants we were working with as well. We started with a very low carbon footprint home. We tried, and physical footprint as well. We wanted to make sure the house was modest. We had to put enough solar panels on. I think 15 kilowatts was what was specified. It was going to be an all-electric home. That was a no-brainer. We then modeled it in Design PH and the PHPP passive house planning package to check its performance 24 times. We then worked with our friends at Detail Green, who ran all the NatHERS data for us. And they also looked at the NatHERS whole of home rating system that's new and coming in, because we wanted to check all those plug-in loads and operational side of things as well, that in the way that that's calculated. As part of the competition, they also specified that we needed to use the footprint calculator to look at our embodied carbon. This was a little bit challenging for a residential scale project, and I think it might have changed this year. We worked with that, but we also used the EPIC database and ended up calculating a few things ourselves to try and make this all make some sense. We also had to look at the payback period to get to becoming carbon neutral, and we've got all the data for that. And we also worked with some industry partners, Carbon Light Logic House to get some, and Fantech to get costings on particular parts of this that we were putting together. And I was working with new and quantity surveyors and ProCalc construction estimator as well. So we cost all of this too. So you can see all of this took quite some time. I'm going to go through the design super quickly so we can get to the actual results. But Australia has some of the biggest homes in the world, the average being 240 square meters, and often homes are a lot bigger. We wanted to prove you could do a 3-bedroom house plus study, 2.5 bathrooms. We could get this in half the size, yet it still is an accessible home. It still has all the functions that you need, and it doesn't have to be huge, because this is a big part of the problem. So it was a focus on efficiency first. The site of this, we wanted to make sure it was a beautiful, functional home in every respect, that we weren't missing out. We weren't trying to do a tiny house. The site was given to us as part of the competition in this orientation. So we simplified the roof to ensure we had enough solar panels facing the right way at the right angle. And we had to look at the outdoor areas as well, and the landscaping as part of that. The design was super simple so that you could use any cladding, any color, all of that. It was really about checking in on this performance. This is also showing it up out of the ground with our timber frame floor. We allowed for ramps or stairs to make sure flexibility, all of that. So all of that was covered, and it was a cute little design. So we move on now to the bigger picture here of all the treasure we discovered. And I'm going to hand over to Andy to go through all of the data, because there is quite a lot of it.
Thank you very much indeed, Talina. Evening, everyone. I hope you're all doing good. All right, so I'm just going to barrel straight along. As Talina mentioned, we put this house into 6 state capital cities. That's all of the state capital cities. And the competition had a winner per state, and we won for Brisbane, which is kind of comical in some ways, to me anyway. But we did, and therefore we were winners, and that's always very nice. The shot you see on the screen is off of the website, where you can find all of this data and interrogate it to your heart's content. And one of the key things to mention, can anyone see my cursor, by the way, Talina? Is my cursor? No, it's not going to work, is it? That's fine. One of the key things is that this data is consistent across all the projects in all the cities, and I'm going to talk now through what some of it means. And I'm going to use the Brisbane one as a sample initially, mainly to give a bit more context to what we've done. I can't move the slides. Could you move them, please?
Yes, I can.
Realize that's the case. Okay, so each city gets four versions. We call them low, medium, and high, and that's relating to the amount of embodied carbon in them, and then chasing rainbows. So the low embodied carbon one every time was a house with a timber floor with bio-based walls. So mostly it was hempcrete until we got to Hobart, where we went to straw bale, and then timber frame roofs, insulated, etc., etc. The medium embodied carbon one had a concrete slab, and the high embodied carbon had heaps of had concrete and brick, reverse brick veneer every time as well. So we were basically stepping up the amount of embodied carbon in each building in a very consistent way. We knew what we were doing. Each one of those three always met the passive house standard. So we assumed it was built airtight, it had mechanical ventilation, it had the right windows, and we optimized them each time so that they just eked over the passive house benchmarks. And that meant that we could we did deliberately downrate the insulation to exactly what it needed to be each time to get us over the line. Chasing Rainbows is the NatHERS version. This is where Luke and Paul at Detail Green came into their own. So we gave them the building, and they knew which city it was in because we told them, because it would have been unfair otherwise. And we basically said, make it as good as you can in this climate. Do whatever the hell you have to do to it in NatHERS to get the best rating you possibly can. We don't care how stupid it might be, but if NatHERS will let you do it, do it. And in Brisbane, they got to 10 stars, which is, you know, is what it is. So it's the only place we got to 10 stars. So that was kind of nice in some ways. We assumed the airtightness for each one of these Chasing Rainbows ones was, we generously agreed that 10 air changes per hour was probably fair. As most people on this talk probably know, the CSIRO currently believe that the average for a new home across the country is 15.4, and anyone who read the report would know that that'd be higher if it wasn't for Justin in Tasmania. So yeah, so that's how we got to that sort of, that's the underpinning philosophy of sort of the different versions each time. As you can see here, this is about the embodied carbon. So we, Tilly mentioned, we use the EPIC database, didn't enjoy using the tools that were suggested, found them fairly impractical at this scale. So built our own because that's what we do. And we calculated to the nth degree the envelope stuff. So how much hempcrete or how much hemp, how much timber, how much insulation, the windows, concrete, slab edge insulation, stainless steel protection to slab edge insulation, all that stuff in the envelope calcs. And then for the total calcs, we just used averages that we were given from the footprint company and just said, well, everything else is the same every time. Tiles, kitchen fit out, flooring, whatever. It's all just the same every time. So that got us embodied numbers. And then we looked at operational energy. And what was interesting, and Brisbane's a great example for this. So the whole of home tool, which is if Victoria ever actually get on board with, you know, getting up to standards, what are you people thinking? Then this will be what gets used. And it, somewhat ironic, well, I find it comical, it assumes that the numbers that come out of NatHERS are actually what happens in a building. So obviously there's a bit of a flaw in that methodology. And what you can see in these numbers, so whole of home is energy, according to what NatHERS says, plus hot water, other fixed services sort of stuff. It's great that we're measuring the stuff and doing it. Basics in New South Wales has been doing it for nearly 20 years. So again, welcome to the party, but glad you got there. And is really important, joking aside. But what's interesting is in PHPP, because it also assumes, as well as maintaining a temperature in a building, it assumes that you'll also control humidity. And therefore, PHPP factor that's really driving those. So, Lena, can you hop on a slide?
Yes.
This one's quick. This is just the insulation values for Brisbane. All I can really say, especially for chasing rainbows, is, geez, look at what you don't need to do to get a 10-star house in Brisbane. How the hell does that work? And the rest of it, really, we can just move on from. Really, I've talked about the different types of I got the floor wrong. The floor of the medium is still a timber floor, and it's when it goes to high embodied carbon that it becomes a concrete floor. And always reverse brick veneer for the Chasing Rainbows house, because as we're about to tell you, NatHERs loves thermal mass. And then payback. So we assumed that we put 15 kilowatts of PV on the roof, and that gave us energy production over a year. And then you're basically just paying back the carbon, and unsurprisingly, the PV production is the same regardless, and therefore the relationship between years of payback is, well, how much carbon did we use to start with? And this was the longest, along with Sydney, for the Chasing Rainbows, was the longest one in terms of paying back. And that's a 15 kilowatt system, which does fit on this roof. But if you start building small houses, especially if you start building 2-story houses, which this wasn't, it's actually hard to fit that much PV on a roof. Can you just go back to the cost? I don't know what I want to say about the cost, but I want to say something. Actually, we'll talk about the cost when we get to the other part. So yes, it costs stuff. We calculate it in a way that I'll explain in a minute. So what did we learn? We're going to talk about the 4 things. Embodied carbon. Okay, these graphs just need a little bit of thought, but they're fairly self-explanatory. So it goes city, 4 versions, then to the next city. So low, medium, high rainbows, low, medium, high rainbows. So you can see that what's happening is that the envelope proportion for each of the houses, for each of the iterations, increases as we go from low to medium to high to Chasing Rainbows. And the Chasing Rainbows is partly because it's a concrete slab, but also then we got the bricks as well. So you see that consistent pattern. And then what you also see is the consistent pattern that the next bar is exactly the same every time, because all the other stuff's the same. So what we're really saying, and I should confess, we stole this idea from Jason Quinn in New Zealand, who's a passive house certifier over there. Like, we measured the stuff that matters. Not that tiles and kitchens and stuff don't matter, but in the purpose of what we were trying to communicate in this exercise, in this research, let's assume that everything else is the same. So we're talking about the stuff that makes the buildings work, and your tiles, while they're very useful, do not contribute to the thermal performance of your home or really to the health of the people inside it. And you can see at the top the PV bit, and we'll come back to that, but that's about 12% of the embodied carbon, upfront carbon, call it which you prefer, and that is not insignificant, and we will make a fairly obvious point about that shortly. So how does this relate to the star ratings? Well, it's a little bit sort of, what's the word? There's a bit of a correlation. Basically, the more embodied upfront carbon you put into the building, the better NatHERs star rating you seem to get based off this data. It increases a bit and picks up every time, and each one of those has a higher star rating and has more embodied carbon. So we can safely say that NatHERs currently seems to prefer embodied carbon. It's not really about embodied carbon, it's actually thermal mass. And in the way that we did this study, those things are the same. Yes, there are ways to use higher thermal mass and not have huge amounts of embodied carbon, but we have to be honest and realistic and say that's fairly uncommon. I know Jeremy's here somewhere. Some people are doing really good work on this, but the vast majority of the industry is not. This just pulls all those graphs back and simplifies it back into the low, medium, high. And yes, there you go. It's the same pattern. It's just put together to try to make it a bit more understandable for people who don't enjoy graphs, which, who doesn't enjoy graphs? This one looks at this idea about operational energy and embodied carbon. Many moons ago, I had the pleasure of being trained by a lovely gentleman, the late great Chris Reardon, who's a guy one of the 2 people who wrote the original Your Home technical manual. And I remember him making the very strong point that it was okay to use a bit of extra embodied carbon because you'd get it back in energy savings later. And that seems sort of sensible, but it turns out it's not necessarily true. And that's just, I think, because our understandings evolved, not because Chris was wrong. It's just the sign of things getting better. And really all this one is showing is that the embodied carbon amounts panned out over those buildings at the bottom, and then we're looking at the operational carbon on top. And what we're seeing is that they're not wildly different for the low, medium, and high each time. And then we've got this big spike in operational carbon on the rainbows versions, in particular in Sydney and Brisbane. And again, that's because, well, I believe because of the humidity stuff that isn't always being taken into account. One of the key things to note is that as our grid decarbonizes, which is obviously happening at whatever pace it may be happening, the operational stuff gets a bit trickier. And you could somewhat flippantly argue that who cares about operational energy because now it's got no carbon content at all. I'm not making that point because I think it's a bit silly. But it is something that's going to play into these things. It's going to also apply to the stuff, because the stuff, if it's made with renewable energy, also has a decreased carbon content. This is sort of good. It's going to complicate things a lot. It doesn't get us away from resources, which we are possibly going to run out of. So this is just pulling everything together again and looking at the ratio of the operational to the embodied. And again, just showing that they are fairly comparable. And therefore, while most of us are currently fairly focused, or for those of us who are focused on anything at all, we're focused mostly on operational energy. Very few people are currently deeply focused on embodied or upfront carbon. That's understandable. There's a lot to get our heads around and get up to speed with. But it's basically as important, and therefore arguably more important. And therefore, this is rapidly going to become what we have to deal with as a bunch of people working in this area. Payback. This is just how long it does take to pay it back. It's all related to the previous graphs and sort of says roughly the same things. The more carbon you use, the longer it's going to take to pay it back. So the key thing here is when you bundle that all up together and you look at the differences, the low, mediums, and highs are all fairly similar at around 10 years to pay it back. The rainbows are up at 15 years. And 5 years is a very, very, very long time. It's 50% more in this case, but also in where we're racing towards 2050 at an alarming rate, dragging everything out by an extra 5 years is probably not the smartest thing we should be doing. So, of course, somebody possibly that I know who just wants to rile me will suggest that we should just build a cheap, crappy shed and put a huge amount of PV on top of it. Sure, you can. I'm not going to live with you or let my kid visit your house. But the issue becomes that A, you need a big enough roof. And if you want to build big houses and blocks of land are smaller, then that's not going to work. But the most important thing is there's a fair bit of embodied carbon goes into solar panels. And therefore, this is actually going to create other issues. And this is before we talk about resilience or health or condensation or mold or any of those other pesky things that people may or may not choose to care about. So in a nutshell, this is probably the daftest idea that we've got. Lots of people are doing it because it's cheap. And if all you care about is money, then this is what you would do. But if all you cared about money, you'd probably sell your firstborn child. So performance gap. So this is interesting. So these are the things we learned along the way to try to understand why things are the way they are. And the answer is often because that's the way they were done and we don't know anymore. And Bob's not here, but it was probably him. So this is just looking at the assumptions that underpin things. Passive House assumes the PHPP, the software that calculates everything, assumes that the building, home or otherwise, all of it, every single room will always be at 20 degrees or warmer. And if it goes below that, some device will turn on and heat will be generated to keep it at 20 degrees. The World Health Organization, those scientists who may or may not know anything about humans, have said that really buildings should not get below 18 degrees, and that's a health issue. And I really did try to find this out, and I have a fascinating email that I can't share, but I'd love to, about how NatHERS works. So this is for bedrooms in NatHERS, only the bedrooms. So firstly, in NatHERS, depending on what you call a room, depends on what temperature it should be, because apparently, as a human, you distinguish between a bedroom and a living room, and your sense of comfort changes as you move from room to room, and also changes during the day as well. So at nighttime, or at these times, I should say, NatHERS makes assumptions about bedroom temperatures. So as you can see, it's 18 degrees just before you get up. It's 18 degrees sort of in the window they think you go to bed. For some reason, from midnight to 7 a.m., you're okay with it being 15 degrees, even though the World Health Organization says that's bad. And the point of this is that what this ends up meaning is that the assumptions that the software makes about how heat is put into buildings, i.e. how much heat is put into buildings, is dictated by the temperatures it's trying to maintain. And therefore, because NatHERS is at some points 5 degrees cooler inside, its target is to be 5 degrees cooler than a passive house in this comparison, that therefore it takes less energy to stay warm because it's staying less warm by design. So, yeah. The other thing, of course, is that NatHERS thinks a bathroom shouldn't be heated at all because it's the one room in your house you're going to be naked and wet in all the time. And therefore, that's a really good place to be cold, obviously. So, yes. All right. So what did I want to say about this? So this is, yes. So this is about the differences about how the software actually spits out these numbers. And so what it's showing is the whole of house calculations is basically, this is predicated off what NatHERS thinks a building will consume in energy, plus all the other services stuff as well. And then the passive house one is all the stuff to stay warm and cool, plus the services stuff as well. So in theory, those two are the same. Didn't test that, but let's assume that they're not too far wrong because it's hot water and how hard can that be to predict? But what you see here is that often these are quite similar. So Adelaide's really similar. Hobart's pretty similar. But you can see, again, Sydney and Brisbane, and again, it's a humidity component to this, that passive house assumes that these issues are resolved. Anyone who's lived in most houses in Sydney will at some point have had a whole bunch of issues with mold and basically shoes with fungus on them and various other things. I've never lived in Brisbane and have no desire to, but I assume that they have similar issues. My mate lives in Brisbane and he told me not so long ago that it was 4 degrees when he woke up. And I'm like, I thought it was hot. And he goes, no, it's bloody terrible for 6 weeks every year, but no one talks about it. So I'm sure why not. Moving on. So equity. So this is one of my favorites. So that's why I get to pick on Talina because she's the only face I can see right now. So for whatever reason, the government have decided that her house in Ballarat, should she build a 7-star home, which of course she wouldn't, but if she were to, that it could use 5 times more energy than a 7-star house that I might build in Sydney. I'm also not going to build one either, but that's not the point. The point is that she can use that much more energy than I can. A 7-star house in Darwin can use 10 times more energy than my 7-star house in Sydney could. Now, in some ways, this is incredibly equitable, and in other ways, this is incredibly inequitable. So it depends how you want to look at it. And to some degree, this is a comment, and I can see why they've done this. This is certainly politically sensible, but we're talking about physics and health and, you know, the future of the planet. So maybe politics isn't the most important thing. So what it basically equates to is what's happened is they've made it so that Talina can build the same house in Ballarat that I can build in Sydney that someone else can build in Darwin, and we can build it basically the same house to pretty much the same specs, and it'll all be a 7-star house. They'll use wildly different amounts of energy to stay warm or cool, but we can all build the same thing. So in that sense, it's equitable across the nation. The inverse to this, of course, would be to argue that why the hell should Northern Territorians get to use 10 times more energy than I do in Sydney, or what would be twice what Talina can in Ballarat, and therefore pollute to 10 times or 2 times or whatever times it is. Like, why is that part equitable? And this is one side of that coin. The other side, of course, is that if people somehow believe that a 7-star home is going to be warm and comfortable and healthy, and in some places, maybe that will be the case. But if you go do that in Ballarat, then maybe you will be, maybe you won't be, but it's going to be very bloody expensive to stay warm and healthy in there because of the fact that they've assumed you'll spend literally 5 times the amount of energy staying warm or cool. I'm fairly confident that we need to move to a system where actually these imbalances are taken out and we start to build houses differently in different places. Funnily, as an architect, we've tended to believe that for quite a long time. It's called site responsive design. And if it's bloody cold, then you should insulate it more than if it's not bloody cold. Not rocket science, building science. Anyway. So this graph looks at the actual amount of energy and this is for the whole building from memory. And you can't really see the three passive house versions because they all blur into each other, because it doesn't really give a hoot whether it's low, medium or high embodied carbon. It's just a building that works. And the embodied carbon's important, but passive house is agnostic on that in particular, but it doesn't mean you can't care about it. And what you can see here is that all the chasing rainbows things, so yeah, great, got a good NatHERS rating, but they all use more energy. And the gap is about 3,000 kilowatt hours per year per home. And then I decided to multiply that by 150, I think it was 150,000 new homes a year, which may or may not be accurate as to how many we build in a year. And therefore that's 450 gigawatt hours of power per year for every year that we continue to build at this pointlessly, stupidly low bar that that New South Wales is about to jump over and Victorians are staring at in a Melbourne Cup. In fact, you like the Melbourne Cup. Why can't you jump over this bar? It doesn't make any sense. Anyway, the lock-in effect. The lock-in effect, look, the Victorian thing, much as I am having a cheap shot at all of you Victorians, this is exactly the source of this is the point. So the key thing is we're going to build, I'll work this out this afternoon. If Victoria builds 180,000 homes in a year, you're about to not build 100,000 homes to the 7-star standard. I'm not saying 7 stars is great at all. It's politically, it's great that they got there. It's better than nothing for sure, but it's still crap. And that's 100,000 homes that are still going to be at 6 stars or thereabouts. And therefore, that's just added to the retrofit market by 100,000 houses. Like, Hamish is busy enough. I'm not sure that he's got time to do that. He's got some mates. That's lovely. I've met some of them. They seem to know what they're doing. They're nice guys. But seriously, we don't need to add to the retrofit problem by building new things that don't work. We've got enough old things that don't work. And this is the lock-in effect. It's building stuff that's inadequate, woefully inadequate now, so it has to be fixed later. And it's got a carbon impact. It's got a money impact. It's got a labor impact. Who's going to do this work? We can't build the houses we currently need at the moment, it would seem. So these things all come together. Bigger looks better. We had a point to make here, which I think was around the fact that the bigger these things are, the better they look on paper. Oh, yes, because everything's measured per square meter. And therefore, if we've done this with costs, so if you've got $1 million house and they don't like the square meter rate, it's like, well, we can build you a house for $1,000 a square meter. Oh, that's great. It's like, yeah, it'd be 350,000 square meter house because we're just going to build some perimeter walls. There'll be nothing in the middle. So you'll need, millions and millions of dollars to do it, but it'll be cheap per square meter. Anyway, it's a cheap point that probably doesn't need to be made. Affordability is the last little thing that we're going to look at. This was super interesting. And we're going to use the Q&A bit for this in a sec. So what we did first was we ran the house through ProCalc, which is an online bit of software that prices stuff that is fairly good, especially early on. It's always wrong, but costing is always wrong. So this, we use Sydney as the benchmark, just because I live here. And then you can see the supposed cost differences in other places. So Melbourne should be 15% cheaper to build a house than Sydney, according to the software. I'm not sure if that pans out. Don't feel like it. Anyway, that's the benchmark for how we started this to get some costs. We then got the whole house costed properly by one of our friendly QSs who did us a favor. And then because he gives me a spreadsheet with all the line items, I went through and I took out all of the different bits that relate to thermal performance. And then we started to tweak and change those based on information from Fantech for the ventilation systems, Logic House for windows, Carbon Light for wall panels, and whoever else, I can't remember now. But basically, we therefore tweaked those bits in order for the cost to jump up and down according to what we were putting in the walls, roof, floor, etc., etc. So as the insulation values changed, we also, the cost was linked to that as well, and it was all connected and parametric, really. So I'm going to pause, drink some water, and ask, but before I do that, I'm going to ask a question, and anyone who went to the Passive House conference cannot answer the question because that's unfair. But these are the supposed costs of this house built in all these places in all of these ways. And as you can see, it sort of goes from about 750 up to about 9 something or other. That's what it is. Can you please, in the Q&A, because I can't see the chat thing doesn't work for me, but the Q&A does, can you please tell me how much as a percentage of that money do you think relates to the thermal performance of the building? So the walls, roof, floor, windows, the ventilation system, because that's performance related, the insulation, those bits and pieces of the building, how much of the cost of this house, or most houses actually, is related to that? Is it half the money goes on that stuff, 80%, 3%? I'll take this moment to have a breather and see who's brave enough to throw there. 30, 15. 30, 15, 20. Nice one, Dom. Appreciate the honesty. 28's very specific. Oh, Ruth's enthusiastic at 7.5. All right, 50. Okay. There's some that are fairly close. All right, cool. Give or take, it's about 25%. It varies a bit. And a key point out of all of this, and I should say that when we first put this talk together and I got to working these numbers out and putting this slide together, I realized that we did a cost analysis on our Thornley house, which was our Envirotecture's first certified passive house project. And we did a detailed analysis on the costs of that one, and which was like 2019, I think it was. I presented at a passive house conference, so it was this weird, like 4 years later, haven't had a passive house conference. Oh my God, I'm talking about the same thing again. And ironically, the answer was the same. It's about 25%. The way that we've been talking about this is what that means is 75% of the cost of a house, or at least a custom designed, custom built house, we should be clear, is to do with nothing to do whether the building works properly. It's insurance, site costs, builder's margin, it's kitchens, it's bathrooms, it's tiles, it's all of that other stuff. Not saying that's not important, not saying it's not necessary, but when we have certain member organizations suggesting that increasing sustainability standards or performance standards is impacting on cost, the short answer to that is that's not true. And there are other factors at play. I've hammered my point. This pulls it all together, but yeah, 23.2 to 26.7%, 25%, near enough, is what it actually has to do with performance. And obviously, if you had a 10% increase in that, that would correlate to a 2% increase in actual costs. I should also say that in the work we did with Carbon Light, we do quite a bit of stuff with them because we like their system. And we, in terms of talking through their stuff, if we built 10 of these, then they get about $20,000 per building cheaper, because in the prefab world, there's a huge amount of time and energy that goes into the setup. And once it's been set up, whether you build 1 of them or 10 of them, the setup costs are the same. So as you get to amortize that over multiple buildings, then it gets heaps cheaper. Again, trying to get big developers to understand that and actually build a row of terrace houses. They all want to build one on the end. It's the hardest one to build. They only want to build 1 of them, and then they wonder why it ends up being really expensive. And then they run away because it was expensive. So it was always going to be that way. But we've had the same conversation with nearly all of them at some point, and it goes the same way each time. So maybe next year will be different.
And to be really... no, that's the last one for you. I've got a few more things to wrap up, but to be really clear, and I think you were, that this is, as Andy said, it's the whole structure, the whole building thermal envelope and everything that makes it work. This is not the increase to add extra insulation or to add your mechanical ventilation. When you look at it like this, that's going to be tiny or negligible based on all of this. So Just to make that really clear, because a few people have been confused by that in the past. So just lastly, we've got the few conclusions to really drive these points home, and then we will open up to questions. So in an appropriate performance world, embodied carbon is as important as operational energy. And the performance gap is unsurprising because we are starting from an unrealistic place. Our housing is all about equity, but it is far from equitable. And the point Andy was making around Sydney versus Ballarat has become really clear to us, and we just think it's not fair for consumers, homeowners, to not understand what they're getting. And we see this all the time, not our clients, but people in the community wondering why their heating bills are insane when they've just built a new 7-star home or 6-star home. And the cost of building is the challenge. We all know it's expensive to build at the moment, but it's not the cost of building well that's the problem. And that's was sort of the biggest takeaway around affordability. So part of the moral of the story here too is around what we value, because every single one of those 24 homes did achieve true net zero. They all did. But what is actually considered valuable? Do we actually care about health and comfort as well? Affordability, making sure our homes are beautiful, functional and resilient, the payback period, or just do we only care about that true net zero? And what we see all the time, people do care about comfort and they do care about health and affordability, and that's sort of what comes to the top. So certainly some of those options are not ticking all of those boxes. And so we sort of wanted to finish by saying that maybe if you pursue the path of considering passive house, you might just find your dream home, your little pot of gold at the end of the rainbow. And we'll put the link in the chat for anyone who wants to go and see all the data there. It's all there. You can download it. You can scrutinize it. You can ask us questions. It's all available. But we just wanted to thank this sort of cast of thousands or however many people helped us out, because it was a really big project, and we're happy to share it and help advocate for better buildings. And so they all lived happily ever after. The end.
In Brisbane.
In Brisbane with 10 stars.
That's probably just as good the second time around watching that. So thank you, Talina and Andy. And I've also realised that I'm probably going to have to switch my my business model to retrofitting all these hundreds of thousands of buildings over the coming years. And that actually was a point that came home on a few presentations when we were in the passive at the Passive House conference. I do have a few questions here if you guys are happy to hang around and answer them. There is a weird, fun question for Talina, and someone, anonymous attendee, has said that she's assuming that you're not currently inside a passive house, given that you've got hand warmers on.
No, I'm not. My office is not a passive house. I wish it was. You know what? It's got tons of thermal mass in here. There's a lot of bricks and a lot of concrete. We don't get any direct sunlight in winter. So this was one of the things where, like, the thermal mass in here is not really working for us. We need more insulation. So yeah, we're looking
pretty spectacular door that I see behind you.
Oh yeah, and we've got some plants. But yes, no, it's not a passive house. We're working on that. That's our next step.
So this is from Brian Guinan, one of the other directors of Builders Declare. Probably a silly question, but could this same principle be applied to encompass the new accessibility codes, which mean a larger footprint? And where and would there be a big impact in your opinion?
Well, the design we did look at accessibility for, I think, just the silver level of the livable housing guidelines, not platinum. But the silver level is what the NCC was starting to, move towards. And so we did take that into consideration and still got 120 square meters of home. So the point was, we don't need 240.
Yes.
Right.
I think people need to really consider the side of their home when they're designing it. You mentioned health. Did you also talk about the health benefits of passive house, or was that not what the study was focusing on?
No, it's passive house, and for everyone who sort of orbits in that space, it's just a given that they're healthy. And
Yep.
we just, yeah. We didn't talk about the fact that
assumed
it's structurally sound and won't fall down either. No one's ever asked the architect whether the building will fall down, but they want to talk about whether it'll be healthy or have double glazing. It doesn't make sense.
This is from Henrik Plus Architects. Hi, Talina and Andy. Would you recommend the use of footprint calculator, and how does it compare with other similar tools?
Andy can answer that one.
We're recording. I'll say I did not enjoy the footprint calculator experience. I believe they have relaunched it since in a way that's more user-friendly. There's a reason I built my own version of the tool. I believe Jeremy's also built something as part of the competition this year for Design Matters. I haven't seen it, but I saw some of the work he did last year, and I would suggest that would be very good. The New South Wales government, through the basics tool, will shortly be doing or asking people to answer questions about embodied carbon as well. So we've been working on that with them. Look, it's really hard because the data matters, but the data is hard to get, and it can be different, and basically you can get almost whatever answer you want. I've still, at the scale we currently operate, I'm still very much in the realm of use things that grow, try not to use things that you dig out of the ground, and basically be nice. And that's mostly been my approach to embodied carbon so far. Trying to calculate it I haven't found a tool that helps me design a better building because of the tool and the information it gives me. Whereas PHPP for passive house performance, I'll learn stuff from that every time, and my buildings get better because of the information it gives me. So sorry, Henry, there's no answer to that one yet, as far as I know.
And it's still early days, but some of the tools, when we were looking into them, it didn't actually matter where you were in Australia. Like anything coming from within the country was considered local. And we know that then it's not. Sometimes like something coming via ship overseas has a lower embodied carbon footprint than something coming by truck across the country. So that's where some of those tools are not really calculating that effectively, especially not for residential scale yet, but they need to. It's
because it's really hard.
Yeah.
There's a reason they're not great at it. It's because it's really complicated.
Yeah.
There's another question around NatHERS. So just remember that you are being recorded. What are your thoughts on the formulas that underpin the NatHERS calculation? And likewise, what are your thoughts that every dwelling in NatHERS must have an unconditioned area?
I will start this by saying I am not a NatHERS assessor, and therefore I have learned stuff along the way by listening to people who know more than I do. My understanding is that the actual calculations and the Cheneth engine behind it are really, really good. And from what I currently understand, I think most of my issues are with the settings that it has, not with the actual calculations. So like bedrooms, like why are they below what they should be? Why can I call a study a bedroom and get a different answer depending on what I call the rooms in my house? It's just illogical. I will say this, even though it's being recorded, what I got told in the email I sent them when I asked them about the bedroom thing was they wrote back and they said, literally, we don't know why it was done this way, but we think it was probably because if we didn't do it this way, the energy use would have gone through the roof and that would have been a problem. I'm like, and they wrote that down, which was the main thing that surprised me, was that they wrote it down and sent it to me. Anyway, and the final question was about an unconditioned space. I think that's stupid. Why should my house be cold in one place and not cold in another, or hot in summer? It's, again, there's no logic to it. Like, it's physics. It's just, yeah, makes no sense.
I enjoyed that answer. I actually enjoyed the presentation, Andy. I did have a lot of lol moments. Did you notice any major disparities or efficiencies based on the climate zone? And this is from Brian as well. Basically, where is the best place to build in Australia?
Oh.
Based on climate?
The Goldilocks climate, right?
The Goldilocks climate's probably some island off the Queensland coast where you can live in a tent.
I reckon Brian's wishing for us to say Perth, because Sydney's going
WA,
to do
yeah.
more humidity, and Brian, you're in
Yeah.
Perth, right? And it's got similar
Mm,
temperate climate.
yeah.
I think
Um,
Brian jumped off for footy training, so we can be honest with him. If we don't have to pander to him.
I think he's probably trying to rile me as well. Yeah, look, I don't think there is I don't think there's an answer to that question. They're all different. I mean, we seek to, for the passive house bits in particular, to meet the passive house standard in every climate, regardless of what that climate was. So it's sort of it's almost a different kind of question. I mean, according to this, if you want to use as little insulation as possible, you go to Brisbane. But then we didn't do Cairns. If you go to Cairns, it'd be a different story. But your humidity, your dehumidification would go through the roof. So
there is a comment here from Georgie just around cost, just around that does seem expensive, and I think that's just a general state comment about the cost of the homes. Look, I mean, I can talk to that as a builder because we cost many projects, and to build a home, unfortunately, at the moment is expensive. Even if you're building a normal shitty 6-star code-built home, it's just expensive. Unfortunately, let's hope that things stabilise. But look, building a smaller home is certainly a good way to start.
yeah, can I add to that though? Part of this is also like it's the nature of custom build, right? Like you guys do an awesome job, and part of that is because there's attention to detail, and you've got the same people on site, and I have a pretty decent understanding about how you probably run your business, and that's awesome. But then, you know, if you contrast that to the project home world, like there's a reason their stuff is cheap, and it's because of all the stuff that they don't do, like have supervision on site. There's reasons that there's these wild differences, but some of the bits they could implement and make happen, and therefore it's a scale issue. Like we build the cheapest houses in the world per square meter. They happen to be shit, but our project homes are cheap as chips per square meter. They spent 40 years or 60 years refining the crap out of how to deliver those things. If they were forced to change their focus to deliver something that basically performs like a passive house, it'd take them a while, but they'd drive the cost out of it from here to Christmas. It can happen. It's just no one's been told they have to do it. And until the law changes, it'll remain a fairly small bunch of people who give a shit making the change in the world. It's the Margaret Mead quote. But hopefully the government will get their act together. Sorry, Hamish.
Look, I did a post yesterday expressing my disappointment around the changes being pushed to next year, and I can only imagine that it was through lobbying from the bigger players in the industry. So it is unfortunate, but look, hopefully. Sorry, go Andy.
No, I've just had a really good thought. It's publicly available how much money those two organisations, which we won't name, but we know who they are, give to political parties. Seriously, how much of a whip around would we need to contribute the same amount to get the same access to get our point across the line?
Are we going to start a GoFundMe page maybe?
Basically, yeah. Contribute more than the HAA by $1. I want my rules in place because that's what happened when they contributed. And if not, why am I contributing to your political party? Sorry.
And of course, we're not naming names, but HIA and Master Builders Association.
I didn't name your name, but yeah, it was them.
No, I didn't name them either.
What was it again?
A few more questions. This is from Cameron, and he does say, sorry, maybe I missed this, but is your definition of a net zero something that has a 15 kilowatt PV, can offset the embodied plus operational energy over X amount of years?
Yes. We chose 15, and the 15 kilowatts was consistent on every building because it was I had enough variables. Otherwise, we could have made the PV system smaller and then calculated it differently, but that's not what we did.
Yeah, it was part of the competition or the challenge that said that you had to put 15 on, I believe, didn't it?
No, it said you could have a maximum, and I just went with that because my brain was already frying. So I think that answers what he meant.
Yeah.
I actually don't know if you're going to answer this question, be able to answer this question, but I'm going to ask it anyway. What is the embodied carbon per square metre in imported triple glazed thermally broken aluminium windows and doors compared to locally made recycled timber single glazed doors and windows?
Different. I don't know.
These are kind of questions that we get thrown out too, and I mean I can never answer them because we do bring a lot of the stuff in from overseas for what we build. And I guess my default answer is we probably out much substance is saying that, you know, the operational cost of the building over the life is hopefully going to pay back that embodied energy. But I probably should back that up with a little bit of data at some point. But, you know, it is probably an interesting thing to unpack at some point, like, you know, but a lot of our building materials are coming from overseas, not just the windows. Or
85% of building materials are imported, apparently. To their credit, I'm very, very sure that Logic Case sent me an email going, here's our certificate for the embodied energy component of our product. So they're a imported timber window with an aluminium thing on the outside and whatever glass you've asked for from Poland. I'm pretty sure that they've got that data. I remember Harley sending it to me not long after we did the study. And I guess the point with all of this stuff with carbon in particular is to ask and have your supplier give you the answer. So ask your local guy what his embodied carbon numbers are. And I mean, to be fair, very few people have got it, but asking's the first step for sure.
Yeah, I mean, and surely a triple or double glazed window is going to perform, you know, a hell of a lot better than a single glazed window, particularly where Talina lives.
Oh, well, and what's the price of the health of your kids when you've got condensation and mold?
Absolutely. This is from Ruth Butler. Would the same principles apply to commercial buildings? Or is it a whole different study?
I don't know.
Well, don't know. Great question, Ruth.
It is a good question.
It depends what you compare it because we basically are playing PHPP off against NatHERS. As soon as you go into commercial, it's different calculation methodology. Yeah, don't know. I mean, Passive House would still perform incredibly well and deliver great outcomes, as she well knows. But yeah, how the differences would be quite interesting.
Yeah, I noticed you made a point in there too around that passive ribbon is available overseas in the UK as a bolt-on to the PHPP that looks at the embodied carbon within the PHPP, which is amazing. And I know there are talks floating around to try and get that to happen in the Australian market as well, because that would help sort of solve that problem, to link it all into the one place for those of us already using PHPP.
There is a few questions in here asking whether or not the recording will be available later, and the answer to that question is yes. We will. I will put it on YouTube tomorrow or over the weekend, depending on if I've got some time. But it will be up over the next few days. This is from Cindy Boland, and there is a few questions here. If you don't mind hanging around just for a little bit longer, I might just cherry pick a few and then we'll call it a night. But this is a boring technical question, which I'm sure you're not going to find boring. With the operational energy compared between PHPP and NatHERS, is that the final energy or primary energy, as PHPP considers PER? Which is the difference? Which is different for different states?
From memory, and if you really care, email me and I will go and check. I'm very sure that I used final energy, which is, so for those who don't know, final energy in Passive House land is literally energy through the meter, whereas PER is primary energy renewable, which includes a factor for the transmission losses. It also sort of factors in the time of year. So you pay more in winter, pay more energy wise, because it allows for seasonal storage, because it assumes you make energy in summer and store it for winter. So I'm pretty sure that I stripped it back to final energy in order to balance the equation, because NatHERS doesn't care about that stuff because they just think that energy is energy.
Couple more. There is a question here from agreement with MB Homes, and I actually did think, as you were talking about this presentation, it would be pretty cool to build this house somewhere. So reach out if you ever want to build a case study. NatHERS is not an as-built tool.
Sorry, Hamish. We want to see them built across the country. So lots of them.
If we can get 10, we get a deal out of Carbon Light. So we just need 10 people to sign up.
And for those who don't know who Carbon Light is, Carbon Light do build certified passive house cassettes here in Victoria. They're a really amazing system. Burkhart's an absolute legend, and I reckon has influenced many builders across Australia to build better homes, myself included. NatHERS is not an as-built tool. Actually, I'll just skip that one. Where the NatHERS people able to alter the window sizes in the star optimization process?
No geometric changes allowed at all. Gaming the system is how we phrased it to Luke.
I'm going to just pick one more, and then I'm going to call it a night. And this is from Darcy Dunn, and it's a long question. Can you clarify that the first 3 houses in each city are all passive house, but you also ran the same building fabric through NatHERS to determine the star rating?
Yes.
Yep. But the NatHERS calculation is not considering the additional air tightness that you can get through building to passive house standard.
Correct.
Does this mean that a 7.2 star house in Melbourne for the low embodied carbon option, for instance, would achieve passive house performance if air tightness was considered?
Say that last part again.
Sorry, the last bit is, does this mean that a 7.2 star house in Melbourne for the low embodied carbon option, for instance, would achieve the passive house performance if air tightness was considered?
Didn't test, maybe. So basically, hang on.
So yeah, I think there's confusion. So the low, medium, and high embodied carbon, the first 3 ones, they all met passive house standard.
They're all passive house,
and it was only the NatHERS one, the Chasing Rainbows one, did not meet passive house standard. But if I understand the question correctly, around if the Chasing Rainbows one got a better air tightness.
That's what I thought the question was. Yeah.
Yeah.
If the Chasing Rainbows also met the air tightness for passive house, I didn't actually check that. Some of them probably would have. They wouldn't have a ventilation system, so they'd be full of mold. But yeah, possibly. I mean, they had great insulation. The key point really would be that most of them would be massively over-spec. So if you dive through the website and look at what Luke did to some of them to get them over the line, like there's just unnecessary, this is somewhere we didn't go, unnecessary materials being used to get a star rating that you don't need if you just make the building airtight. And obviously now, again, not for Victorians, but because as of when your state does adopt the new code and the new software for NatHERS, there will be an ability to change the air tightness in NatHERS, and I believe that there will be a way to legally commit to achieving a particular air tightness result. And that's going to be very, very interesting, because builders fundamentally will get to choose what they commit to before they start a job, which of course brings the question, what happens if they miss the target?
Well, I mean, it's probably not common knowledge, but the NCC does assume 10 air changes. So I guess technically we are obliged to build to 10 air changes. So an astute homeowner theoretically could test their home, and if it doesn't reach it, that builder is liable to come back and actually get it to 10 air changes. That's my understanding anyway.
You're not obliged to, if you can choose to go that way, but you can do all the other things to avoid that. But this new thing will be different, because it will be on your NatHERS certificate, and it will say that you'll do this, and achieve an air tightness result of this. How they're going to enforce it, it's going to be really, really interesting.
Mandatory checks and blower door checks, and blower door tests. Mandatory insulation tests.
You would assume, but let's be honest, how well have inspections and building quality control gone over the last 30 years?
Good point.
But that
Good
will
point.
help reduce the performance gap. It doesn't get rid of that completely, but that will help at least to start to see that, because that's the other problem we didn't really touch on, that what's being built is not what is being designed unless you're going down that passive house path and improving it.
Yeah. I'm going to wrap it up. Is there anything else you want to say before I do some little closing statements here?
I've put some of the links in the chat there, but I don't know if everyone can see that. So I'm sure you can add them to the show notes, or, you know, the webinar, the YouTube notes later, if anyone wants to go and all of the info.
Yeah, so if everyone just clicks the little chat box there, Talina's put a couple of links in there for everybody to see. Thank you so much for coming on tonight. And I did mention before we came on today that this was actually the biggest registration that we've ever had for one of our Builders Declare webinars. So it must have been the famous people that came on. So thank you for doing that. I do want to give a bit of a shout out to the podcast that we do. So that's called the Sustainable Builders Yak. We're up to episode 18. And in this one, Simon and Brian catch up with Dr. Martin Ander, and he's an environmental engineer and expert in urban water efficiency. And it's actually a really, really interesting podcast. So definitely check that one out. We've got a couple of really cool webinars coming up. Next month, we're joined by Cameron Munro from Passive Analytics. And we are really going to nerd out on some building sites. So I'm really, really pumped and excited about that too. And I did notice that Ryan Stratton from Core Collective was on this webinar as well. And we are going to get him on because he's bringing out this amazing product called Clinker. And it's an expanded clay product, which we are going to test on one of our projects as a sub-slab insulation. So, you know, trying to get out, you know, some of the foam that's in our building. So pretty excited to get him on to talk about that. Thank you to everyone again for joining us on today's webinar. It's been a really fantastic turnout, and I hope everyone's got something out of it. If you want to get in contact with us, info@buildersdeclare.com. You can join the conversation on our Facebook page or on our Instagram page. Jeremy Spencer's really active on that one. Again, Talina and Marla and Andy, I really appreciate you guys coming on tonight, and thank you for a fantastic presentation.
Thanks for organising, Hamish. It's been awesome.
Awesome. Thank you, guys, and thanks for everybody for coming along. Cheers.